Welcome back, Chemistry 30. So this is the next video in the EC1.5. So I left you with this. We figured out which reaction was at the anode, which one was at the cathode, and I left you with setting this up. So let's take a look. So at the cathode, we were gaining electrons, plus 0.536 volts. And at the reduction potential at the anode, so we're losing electrons, negative 1.66 volts. So the E cell is going to be plus 0.536 volts. Negative, negative, that's going to give me a positive overall. So plus 1.66 volts. So that's going to give me an overall of 0.220 volts to the positive. So that will be a positive amount. All right, so that means and of course we should get positive amounts for E cell. Remember earlier we stated if we're not getting positives, that's going to be an issue, and that's going to be coming up next actually. So we should get positive. We could have negatives for anodes and cathodes, etc., but the overall should be 2.2. That tells us that we're going in the right direction, and it's going to occur naturally. It's going to be spontaneous. So for each half cell in an electrochemical cell, the standard reduction potential provides a measure of the tendency of the reaction to occur. The more positive the value of the reduction, the greater the tendency for the reduction under standard conditions. In any electrochemical cell operating under standard conditions, the reduction potential value for the reaction at the cathode, here's what I just mentioned. So the cathode must be more positive than the reduction potential at the anode. So we should always get a positive value here. So quite often both of these are negative, but as long as this one's more positive, we know that the reaction will occur spontaneously. So we have the spontaneous flow of electrons when my cathode number is more positive than the anode number. And you'll see that is true in all these. Cathode, more positive than this. Cathode, more positive than that. And I know that that reaction is going to be spontaneous, occur automatically. So if we go to the next page, the electrode with the more negative value of E red to the electrode with the more positive value of reduction. So again, cathode. And this little diagram kind of illustrates that too. Cathode more positive than the anode. The fact that the standard cell potential is the difference between the standard reduction potentials of the cathode and anode is illustrated graphically here. And notice that the more positive value identifies what the cathode is. And the difference between the two gives us the cell potential, which has to be a positive number. All right, so let's take a look here. So how do we look at that? So here we have determining the half reactions at electrodes and calculating the cell potentials. So here we have two reactions, and it says use the data on Appendix E to determine which of these reactions is at the cathode and which one's at the anode. And then once you do that, do what we just did, figure out the potential. Okay, so what we have to do is look up these values. So let's take a look. So we don't know which one's at the cathode and which one's at the anode until we look at this sheet. So cadmium ion going to cadmium solid. Cadmium, oh, here it is right here, CD2+, right? And it's a value of 0.403 to the negative. So let's write that down. So let's call this E, the reduction potential of that is, what did I say, minus 0.403 volts. And let's look up tin. Now it's the tin 2 version, SN2+. So let's look up that, SN2+. Careful because there's an SN4+ here as well. Minus 0.136. Minus 0.136. And that's the reduction potential of that. So what we have to look here is which one is more positive. And of course, we can see more positive value. So of course, that has to be the area that's receiving the electrons. That's the cathode. So I could put positive value there for this is the cathode. There we go. So that's all we have to do for that. Now I'm going to set up the reaction to how it's supposed to be. So let's take a look here. So we'll call this A, what we're doing here. So we'll write down the cathode reaction and the anode reaction, because it says what half reaction occurs at the cathode and which one's at the anode, so we should mention which is which. So the tin is at the cathode, so it's just set up exactly like this. It's going to take in those 2 electrons to become this. And of course, I can just rewrite this, oops, minus 0.136 volts. And at the anode, I'm going to write the arrow underneath so it's actually lined up for a change. This is where the electrons are given up, so it's the reverse of this. So CD breaks down to give us CD2+, and the release of 2 electrons. But I still write down the reduction though. I still write as if it's reduction. Minus 0.403. Because the way we have this equation set up, the E cell set up, it automatically works everything out. So there we go. So we have the 2 reactions at the anode and cathode. So now we can set this up. E cell is the reduction potential at the cathode minus the reduction potential at the anode. So the reduction, and of course, yes, at the cathode, right? The cathode is where we got the GR, reduction. The anode is where we got the LEO anode, and GR the GR cathode. So reduction is my more positive number, right? My more positive number is always at the cathode. So even though they're both negative, the one that's more positive is the cathode. For the reaction to work, of course. Okay, so we got that. So E cell 0.137 there. Negative, negative, that gives me a positive. 403. So E cell works out to be plus 0.267 volts. So we should get a positive there. If I don't, that means the reaction is not spontaneous. And again, that's going to kind of kick into the last section that we have for here. All right, let's look at the next side here. So this is set up doing the same thing, but not giving you a little bit less information here. So that other one, they gave you the 2 half reactions, right? Here they're kind of like shortening it up. Here are the half reactions. You figure out what it is. So over here it says, what's the half reaction at the anode? Well, we could figure out the one at the cathode too as well. And then what is the standard cell potential? So let's look at this, cobalt 2+ and cobalt. So cobalt 2+ and cobalt, let's take a look here. So here it is here. Cobalt 2+ plus 2 electrons gives us cobalt. So I'm just going to write that down just as is. So cobalt 2+ plus 2 electrons gives us cobalt solid. And the reduction potential for that was, where are we? Cobalt 2+ minus 0.277. Okay, and the other one's kind of a weird one. Silver chloride and silver. Silver chloride and silver. Silver chloride and silver. Well, that's this one up here, I believe. Silver chloride and silver. So we have it right there. Silver chloride plus 1 electron gives us silver, and chloride minus. So silver chloride plus 1 electron gives us silver and chloride. And the reduction potential for that is, let's see here, silver chloride and silver plus 0.222. All right. So plus 0.222 volts. And of course, looking for the more positive one. More positive. Therefore, cathode. when's the cathode. So I can identify the cathode reaction and the anode reaction. We could get the overall equation too, but the question doesn't ask for that. So cathode, CO2 plus 2 electrons gives us CO. And the reduction potential for that, all right, and the reduction potential there was, oh, I think I have that backwards, don't I? Yes, for some reason I thought that was a positive. So we will have to just do this. There we go. Sorry about that gig. So that is not the cathode. So without making a big mess here, let's just change this to anode. Hopefully you caught that as I was doing it and said, hey, Casper, you made a mistake. Second time I did that. So the anode is going to be this one. So yes, so the anode is the more positive one. Oh, sorry, the cathode is the more positive one. So that this is the anode because it's more negative. Whew, talking myself in circles here. And the cathode, that's the more positive one. So that is my AgCl. So Ag plus Cl, breaking down into AgCl. And I see I did that backwards. You know what? Hey, since we have this full page here, ladies and gentlemen, let's just do it right. Let's do it right. Okay. So let's back up the truck. So the more positive one, it's not rocket science, even though I thought it was for a second there. So this is the cathode. So that, I need to write it in this form. So let's do that one first, because I wrote that equation backwards and it's just a mess. Okay, so cathode, it's gaining the electrons, so I write it just like this. So AgCl plus electron gives us Ag plus Cl minus, we'll get this right yet, plus 0.222 volts. Okay, now we'll get the anode right, because I wrote it, I have to write it flipped, right? It has to be showing giving up electrons. So cobalt going to cobalt 2 plus and 2 electrons, and my reduction potential needs to be less than the cathode, and it is negative 0.277 volts. All right. And of course here you can change this to 2 here. 2 electrons, 2 electrons. We could double everything up here, but we don't need to, because again, we're not concerned about the overall reaction. We want to figure out E cell. And changing the coefficients by multiplying by 2 or multiplying by 3 does not change that E cell value or the reduction potential. So I can just simply leave it as is. So the reduction potential at the cathode minus the reduction potential at the anode. So at the cathode, plus 0.22 volts minus 0.277 volts. Then we can whiz through this. This is easy street now. And these questions aren't easy. Just don't make the same little error I did with the error switching. So that works out to be plus 0.499 volts. There we go. There we have it. So in the assignment, the first part of it is more qualitative. And then after that, questions are very similar to what we did here. There's one there, number 6, in which you have to kind of guess and check a little bit to see which is going to give you the highest E cell value and which the lowest. But it's, again, it's not that bad either. It's just simply looking at what we're just doing. And there's, of course, shortcuts that we can do. All right. So you have any questions, ask, and we'll see you again.